everyone, Chapter 3, Periodic Table. In 3.2 Periodicity, Electronegativity, you will learn how to define it and the variations of the electronegativity. Electronegativity, it is a relative ability of a bonded atom to attract the shared electrons. So for the example here, okay, we have the two hydrogen atom. In between of these two hydrogen atom, there are two dots represent for the shared electrons. Same for the atom of the hydrogen and fluorine, there are two dots in between of the hydrogen and fluorine, so that is the shared electrons. So for the hydrogen, okay, because it is the same types of the atom, so there is no, we cannot see the difference electronegativity between these two atoms. But for the hydrogen fluorides, okay, we see that fluorine, it has more electron compared to the hydrogen. So you can see that the shared electron, it will more attract to the fluorine because fluorine has more electrons. So from this electron cloud, you can see that the electron cloud for the fluorine, okay, it has more electrons, so that's why the bonded electron or the shared electron between hydrogen and fluorine, it will more attracted to the fluorine. So H2 is the non-polar covalent bond and HF, this is the polar covalent bond. So this is a common element electronegativity across period and down a group. So across a period, okay, we can see that the electronegativity is increased, but actually for each element it has its own value of the electronegativity. And down a group, okay, the electronegativity is decreased. Okay, this is relates to the size. So let's see, down a group, what happened is, we know that down a group, number of shell principal quantum number increases. So thus, okay, it will cause the shielding or screening effect increases, and the interaction between the valence electrons and nucleus weaker, so the atomic size increases, and ability of an atom to attract the shared electron decreases. Okay, so what happened to the electronegativity? It will decreases. As the atomic size increases, ability of the atom to attract the electron is decreased. So that's why the electronegativity decreases. Across period, okay, proton number increases. And why it will cause the effective nuclear charge increases, and the interactions between the valence electron and nucleus stronger, atomic size decreases or smaller, and ability of the atom to attract the shared electron increases. So it will cause the electronegativity increases. So as the size smaller, so it will cause easier for the atom to attract the shared electrons, and that's why the electronegativity increases. Okay, let's see the last part of the 3.2 periodicity. It is about the period 3, which is acid-base character. So oxides of the element period 3. So the element 3, we know that it is a sodium, magnesium, okay, and for the sodium and magnesium, the oxide of this element is the for the sodium Na2O, sodium oxide, and magnesium oxide. So what is the type of the oxide? It is a basic oxide. Okay, and for the aluminium oxide, it is the amphoteric, and the type for the silicon oxide, phosphorus oxide, sulfur trioxide, and chlorine hexaoxide. Okay, this is an acidic. So this is a type of the oxide for the element period 3. It has a basic, amphoteric, and acidic. And what is the type of the compound? Okay, for the first three element of the period 3, it is the ionic compound, and for the silicon antichlorine, it is a molecular. Okay, let's see the acid-base character of the oxide of element in period 3. So elements, it will react with the oxygen to produce oxide. So this is how the oxide is formed from the element period 3. Okay, for the sodium, okay, how it forms sodium oxide, it react with the oxygen. Same for the others. And silicons, okay, phosphorus, sulfur, okay, and so on. Alright. Okay, sulfur, it will form sulfur dioxide, and from the sulfur dioxide it react with again, okay, with the oxygen, and it will form sulfur trioxide. So next, let's see the basic oxides. Basic oxide is formed when the sodium and magnesium react with the oxygen, and it is an ionic compound. When it reacts with the water, it will form sodium hydroxide. That's why it is basic oxide. So this is the equations, okay, which is sodium oxide, when it dissolve in water, okay, it will form sodium hydroxide. So it shows that it is basic oxide. So magnesium oxide is insoluble in water. However, it does react with the acid to produce salt and water. So this is the equations, okay, because it is insoluble in water. So this equation shows the reactions of the magnesium oxide with the HCl. Okay, HCl is the acid. So when it reacts with the acid, it can or dissolve in the acid. So it shows that it is basic. Shows that magnesium oxide is the basic. So this is the equations to shows the magnesium oxide is the basic oxide. Amphoteric oxide. Amphoteric means that it can act as an acid or base. So when it forms when it reacts with the oxygens, and it is ionic compounds. So this is the equations when it acts as acid, which is when it acts as acid, it will react with the base. So it is acid, so it will react with the base, and because it is solid, so must have water, then it will form sodium aluminium hydroxide. Okay, so this is the equations that shows it is acid. And when it acts as a base, okay, this is the equations, which is it react with the HCl, acid, so it shows that it is base, and it will form aluminum trichloride and H2O. Okay, acidic oxide form, okay, when silicon react with the oxygen, it is ionic and it is insoluble in water. However, it does react with the base to produce salt and water. So this is the equations, okay, to shows that it react with the base. Okay, it is acidic, so it react with the base. Okay, then acidic oxide, it is formed when these three elements, okay, react with the oxygen. So it is a covalent, not ionic, it is covalent. Okay, it's molecular, and type of the compound is the molecular compound. And oxide react with the water to produce acidic solutions. So this is equations, okay, when to shows, okay, it form the acidic solutions. Okay, when it dissolve in water, so sulfur trioxide, when dissolve in water, it will form sulfuric acid. Phosphorus decaoxide, when it dissolve in water, it will form phosphoric acids. And Cl2O7, okay, it will form perchloric acid. So this is a characteristic of the oxide for the phosphorus, sulfur, and chlorine. Okay, that's all. Thank you.